Good morning, good afternoon, good evening to wherever you are in the world. Welcome to the L1X Developer Workshop. This is the first developer workshop that we will be conducting online that will help you to dive into the L1X protocol, understanding its components that are closely working together to make interoperability, or what we like to call XTalk, get adopted. In this workshop, we will be looking at the L1X protocol. We'll be looking at the most important component of it, which is the innovative XTalk. And we will also deep dive into certain coding aspects of things, where we will analyze the new types of contracts that we have released. And we will also help you build with the software development environment. In this video, let's try to have a look at the L1X protocol and understand what components constitute the protocol. The L1X node software. The L1X node software stands as the core container on the blockchain network. It includes services such as consensus mechanism, the virtual machine, XTalk, and most importantly, the storage systems. All these components work together to provide a holistic and a comprehensive layer 1 protocol that will help you to build cross-chain applications from the ground up without using any bridges. The node software is a core component of the L1X infrastructure, and the nodes at the L1X infrastructure are divided into three main types. The first are event listener nodes. The second one is the execution, and the third one is the signing and the broadcasting nodes. The event listener nodes have the role of listening to the events, validating those events, and sending it to the transaction execution environment. The transaction execution environment node allows for the virtual machine to execute these contracts and prepare payloads or conduct business logic and application flow as per the contract requirements. It provides a deterministic way of implementing smart contract execution strategies. The signing and the broadcasting nodes are responsible to sign payloads and send it to the right destination address or contracts. We will be using Gitbook as a source of understanding the components as we progress throughout the workshop, which will be divided into various videos, and you will understand where we will first of all explain terminologies and components in a simple manner, and then we will take a deep dive into them. Moving on, the most important concept or the foundation of the infrastructure that we are building at layer 1 is providing modularity, which if you take a step further into building a cross-chain app and expanding what you would like to do in the decentralized environment, we will allow you to pick various kind of situations or components or of the technologies where you will be able to execute those components in isolation. For example, if you decide to host your own signer and broadcasting node, you will be able to create guardrails around those nodes that will help you to further push the boundaries in terms of how you want your application to be built. The state management side of things at L1X, we have focused upon a column family database and a key pair value. So it's a hybrid state management features, and it ties up amazingly well with how the nodes operate on the network and how the virtual machine will retrieve and store information back into these state management features by loading and saving an instance or a state of a contract in the contract execution lifecycle. One of the most important part of any layer 1 is its virtual machine. Moving on to the virtual machine side of things and having a look at the innovativeness that we bring to the table, the L1X virtual machine is built from ground up, which allows developer to build contracts not only in Rust, but also with Solidity. There are three types of transactions that go through the virtual machine, or three types of smart contracts. The first is the L1X contract, which is, for example, the L1X fungible token or non-fungible token that do not need to interact with cross protocols or cross-chain protocols. This contract executes into the L1X environment itself. The next one is EVM-based or Solidity contracts. L1X VM has been built from ground up, but is also interacting with an EVM instance that it closely works together with features such as the EVM instance manager and even function call manager that beautifully allow for cross-contract calls between the L1X VM and the L1X EVM. Developers can build Solidity contracts and deploy it on the L1X EVM and use the L1X contracts to interact with these contracts that they have deployed on the EVM. This provides a way to control the manner of how you want your Solidity code to be executable. Last but not the least, we introduce Xtalk, which is a completely new type of a smart contract that allows you to build cross-chain applications in a way that are modular, that are scalable, that are quick, and are also secure. We will deep dive into what Xtalk is, it's an infrastructure, and what the components associated to Xtalk are. The L1X VM follows a dual compilation process. And we have adopted this model because we believe WebAssembly to be the language of the internet, while eBPF, the extended Berkeley packet filter instructions, run beautifully in a secure manner into the virtual environment that we set up on the node. Rust contracts are first compiled into WebAssembly. Then our proprietary compiler compiles the WebAssembly code into eBPF, which is then executed on the RBPF system. Of course, as I mentioned previously, the virtual machine also helps with cross-contract calls. So in cross-contract calls, you can do a cross-contract with L1X VM contract itself, or you can do a cross-contract call across L1X VM and EVM. One of the most important tools that we provide to the developers are the software development environment, which will be available to you when you see this video. There is a separate video associated to that, which you can load up and install the software and start deploying contracts in less than 25 minutes. We focus more on the strategic approach on how contracts can be built with us. For example, when you look at the L1X contract compilation process, we have adopted the concept of modularity, where if a developer's destination contract or the bytecode is WebAssembly, that can be executed along with eBPF. Now, providing this kind of modularity in a virtual machine at the protocol level not only allows for more adoption in terms of application requirements that require this kind of execution runtime, but it also allows the choice from the developer's perspective in a modular approach and in a secure way that the bytecodes remain deterministic. Moving on to the consensus mechanism. The L1X consensus mechanism is based on proof of X, which is a hybrid consensus mechanism, which introduces proof of stake and democratic validation. The objective of this is to progressively move towards a clustered environment where low-powered devices will be a part of the consensus in the long run. Proof of stake at this point in time allows us to secure the network. But in the coming future, where there will be devices that initiate transactions by themselves, will be a significant part of the proof of concept in terms of the consensus mechanism. The consensus mechanism grows like a leaf, where you have three types of nodes, as we discussed earlier. And the reason we have divided the nodes into these three types are also based on validation strategies. We will deep dive into these type of nodes a bit later. Moving on, Xtalk. Xtalk is the new way that developers will build cross-chain contracts. Xtalk is a bridgeless infrastructure that's designed for seamless interchain communication. Its primary function is, of course, to process, but more importantly, to also validate and store events and payloads that can be transformed and sent to the destination chains and their contracts. It is guided by a set of predefined rules that are specific to every type of event. The architecture enables a deterministic approach of rules on various types, all facilitated by this Xtalk flow contract. Think of Xtalk as the bridge killer. Xtalk is the ability to build what you want to build without thinking where you want to execute. Imagine a scenario where you are building a website and you had this website designed and built with target in mind, which was, I want to run my website on Google Chrome on Mac versus my website should run on Ubuntu systems on Firefox. I don't think the website would have the adoption that it has today, or websites would have those kind of adoptions. That is why we introduce Xtalk, which is a completely new way to build contracts. And we like to call this the Xtalk flow contract. Now, the flow contract includes a subset of the other contracts with it. It has the xtalk port contract. It has the event configuration, such as validating the events, scheduling the events, and also bringing real world information and serializing it into the same event format that you would use when you receive it from the other protocols. This provides a standardized way of listening to information that is coming from outside the protocol and process it internally. It includes various other contracts, such as the xtalk commander contract, which is your central point where developers will be building these contracts that takes in the event configurations in details, and also the payload preparation configurations. These contracts process instructions based on what we like to call the xtalk messaging standard or the instruction sets. What constitutes the Xflow contract? Xtalk port, as we just saw, allows us to receive incoming events, and these events are validated, it are scheduled. The xtalk commander contract has three main components. The first one is the contract storage, where it allows you to store certain type of information into that particular contract. You don't need to load the whole contract and store information. You can retrieve information based on events, based on payloads, and based on various other keys that you will determine while you build your contract. We will get into the coding aspect of it as well. The second one is the flow logic. The flow logic takes two main important components, which we will see later on in depth. The saving of the event data, and based on the event data that you just saved, the preparation of the payload. One of the most important components of the commander contract is the business logic entry point. Let's say you were to receive an event from chain A that a user has transferred a certain amount to a contract, or the user has an NFT that has been applied to that particular user's account. Based on that event, you want to process another set of information where you would like to request this user to join your business or buy a certain type of a product in Web3. You would be able to do that using this business logic. The business logic controls the execution flow in terms of how you transform your payload, but also how you save information back to the storage. The most unique aspect about the business logic is that it is completely modular. You can borrow business logics from other contracts. For example, if you receive an invoice and you need to pay a certain part of the invoice to the business account and a certain part reserved into a government deposit contract, which takes your GST, you could use the government's business logic to execute this flow. You could stake your assets on one chain and borrow the assets on the other chain to enable your trading. The xtalk Helm contract is like a router where it understands the payload that you are preparing is for what type of a contract. Now, what the router does is it understands the payload signing node that you can host yourself or use the already existing nodes and allow to send your payload to these nodes to be signed. Once these payloads are signed, it is sent and broadcasted to the correct addresses. The router also comprehensively puts together a temporary space for contracts, such as the L1X VM contract and the L1X EVM contract. These two types of contracts can cross-call each other. And for example, if there were two liquidity pairs available on two different types of contracts, and if you wanted to do a swap, you could recognize the best route using the xtalk Helm as well. But not only using the route, also being in a position that if you do decide to go ahead with that swap, you can send your payload to another signing and broadcasting node, keeping it more secure. Instead of using 5 to 6 different types of contracts on a bridge, all you need is the xtalk flow contract interacting with your liquidity pool contracts on source and destination chains that handles the destination business logic for the payload creation and also the broadcasting aspect of it. How does it compare to bridge? What is the difference between xtalk and a bridge? First of all, let's look at the number of contracts. xtalk only needs one contract, which is the cross-chain swap flow. Let's compare a cross-chain swap application. The cross-chain swap flow, as we will see later on in the code, allows you to save the event data that a user has actually transferred certain amount. Not only that, It allows you to even go and execute according to the destination payload. It allows you to serialize it as well. So if you were sending the payload to EVM versus non-EVM based chains, you don't need to worry. Your smart contract will prepare the payload according to where the destination has to be. A bridge would need to implement 5 to 6 different types of contracts as well, where you have your event validator, a router contract, event listener, Oracle, numerous other contracts that even humankind may not be aware about. This provides a secure way of building it. You are taking Xtalk, you are implementing an execution environment, which is a virtual machine. You have your business logic that is executed on the virtual machine. And you also have the ability to store information processed by the business logic and save that event data for later processing. The contract complexity is pretty distributed. We don't call it decentralized, it's distributed. The state management is within the contract. So you can, as I mentioned previously, you can store your state within the contract versus storing it across different types of contracts. Event handling. You can handle these events directly in the contract. Not only that, Oracle information and event information can be synthesized and standardized into a single message format that your Xtalk contract will understand. In a typical bridge, these are handled by individual specialized contracts. It's also the ability of the cost. Imagine deploying 6 contracts, updating these 6 contracts that need to be updated in a way that each and every contract understands the next flow. The verification process, unified within the single contract. So the verification process allows you to verify the information within the single contract as well. So there are event listener nodes that listen to these events, validate it, and provide that particular event data to the transaction execution node. The verification process on a bridge is not synchronous in a way where if we do execute a certain payload on a destination chain, when we receive the information back that the event has been processed, there is no way, there is a deterministic way of proving in a certain timeline that the response has been received, because these are logics implemented across different contracts. Storage interaction. We can store and retrieve event information and apply transformations to the event that we receive to create the next payload by the storing and the saving methods that are implemented intrinsically within the contract. Again, it's spread across multiple different contracts on a bridge. The interoperability side of it, Xtalk is interoperable by nature, where it is designed for cross-chain applications. A typical bridge requires also external connectors like oracles on each chain involved. And this is where your aggregation of business logic and events that you listen from outside the protocol can be saved and retrieved at any point in time. Security concerns, we all have seen the hacks that have happened on the bridges because of so many loopholes that these bridges bring on the table. The only security concern for Xtalk is its decentralized point of failure, because it's a contract in itself. It's an interface that we have built for developers to integrate in their cross-chain type applications. And there is a huge amount of validations that are done in terms of the development environment before the contracts are deployed. Execution efficiency. It's more efficient, of course, because you only have a single contract versus you have 4 or 5 different contracts. And the users at the end of the day will be paying less gas fees as well, because you are only interacting with one type of contract on these source and destination chains. You don't have to build a cross-chain application through Xtalk. You can use the L1X infrastructure as well to host multiple forms of execution strategies. But because we believe that in a Web3 environment where adoption is the key to the success of decentralization, Xtalk is here to provide that infrastructure to make that happen.